In this video, we'll show you the flame retardant qualities of the BioLime plaster coating system for interior and exterior architecture. It provides significant fire protection to the home office building or commercial structure that is coated and protected by BioLime. Why is this important? Well, most of today's architecture contains flammable building materials like wood and includes sheathing applied over the wood, which then is typically covered with paint, cement stucco, synthetic coatings, and other types of potentially flammable materials. Throughout the residential, commercial, institutional, and government sectors, fires occur often, create property damage in the millions, and unfortunately, injury and loss of life to inhabitants. To prove the point, we recently undertook a test. We set up a section of ICF wall foam board coated with BioLime and exposed it to a direct flame with a constant burn temperature of 2000 degrees Fahrenheit. We applied BioLime's 3-layer system designed for ICF substrates. We checked the status every hour. The test took place on our business premises in the summer of 2025 and was performed on a hot Texas summer day with outside temperatures around 100 degrees Fahrenheit. We originally created this setup to meet the 4-hour uninterrupted burn test that ASTM requires. What we set out to illustrate was that our BioLime coating would endure through a 4-hour burn test while protecting a sensitive building system like ICF, Insulated Concrete Form. By intention, we did not fill the cavity with concrete because we wanted to assess the backside of the test assembly to evaluate how BioLime was actually protecting the ICF foam, which is highly susceptible to degradation and complete failure when exposed to flames or excessive heat. At the 2nd hour mark, the temperature difference between the intense hot center surface, the white spot, and the outer edge of the test surface is significant. Our digital infrared temperature instrument measures up to a maximum reading of 600 degrees Fahrenheit and displays an error code beyond that level of heat. As we move to the rear of the panel, the flame in the front continues to burn above 2000 degrees Fahrenheit. As we touch the back of the styrofoam panel, it feels surprisingly cool. The temperature reads around 130 to 140 degrees. At hour 3, temperature readings on the back side of the styrofoam panel have risen only slightly and are around 200 degrees. In the meantime, the flame in the front continues to burn at over 2000 degrees Fahrenheit. We're taking our final reading at the 4-hour mark. On the back, there is no degradation of the ICF wall styrofoam and temperatures remain stable. Seeing the extraordinary results that BioLime provided, we decided to continue testing and complete a full 8-hour burn test. At 5 hours, with the flame still burning over 2000 degrees Fahrenheit, there is no significant degradation on the backside. The red tape that was placed on the seam remains intact as well. Surface temps are stable, while the interior cavity measures from 200 to 250 degrees. We're on hour 7, and on the front side, we have no delamination whatsoever. The material remains solid and the BioLime coating is married to the ICF without any pull away or separation. The hot spot is intact and there's no material down at the ground. Interestingly, the BioLime coating itself is cool to touch. Being careful to avoid the flame, one can even place their hand on the surface adjacent to the flame without feeling high heat. The material shows no signs of degradation or delamination. On the back side, we see very minor deformation of the styrofoam. Our red tape still has not melted or fallen off. The temperature readings are consistent with what we've seen in previous readings, measuring from 150 degrees at the seam to 275 degrees in the cavity. For the final observation at the 8th hour, we see the BioLime coating is still fully intact and bonded, no signs of delamination, and as we move to the outer edge of the test area, temperature readings are around 120 degrees. On the back side, the ICF styrofoam is only slightly deformed, however, it's not melted or pulled away. The red tape hasn't burned either, and temperature readings are consistent with what we've seen throughout the day. Given the fact that for the full 8 hours, we've had a flame burning at over 2000 degrees Fahrenheit directed at the front of our setup, this is an amazing result. Our goal in performing this test was to evaluate and prove the significant fire retardant and protective qualities of BioLime-coated surfaces. Most cementitious stuccos and coatings will trap heat and allow it to penetrate into the substrate. In contrast, BioLime vaporizes heat instantaneously, preventing subsequent damage at the very onset of trouble. It's the only one that diffuses heat faster than a flame can deliver it, protecting buildings and saving lives. Fires are extremely devastating, and in any fire disaster scenario, even just 30 minutes of fire protection can make a huge difference, giving firefighters and first responders the additional time needed to extinguish fires and save lives. BioLime coatings far exceed the effects of traditional fireproofing by providing real fire protection, even under harsh conditions and against extremely high temperatures and for prolonged periods of time. This makes BioLime your best choice for protecting and preserving buildings and property. We imagine a future where architecture that utilizes BioLime's technology will save millions by preventing fire damage and saving lives. If you would like more information, please reach out to us via our website, visit our YouTube channel, or call us. We'd love to hear about your building or project and how we can help you.